Welcome to Lesson B01, Conditional Statements. Hopefully your Unit A test went well, and now we're going to do something completely new and different. So by the end of this lesson, you should be able to explain conditional statements and identify their parts, explain converse, inverse, and contrapositive statements, and find the truth value of a conditional statement. So looking at these statements here and the map, determine if each statement is true or false. Take a moment to pause the video and do this on your own. If you are in Massachusetts, then you are in England, or in New England. This is true, right? The state of Massachusetts is in the larger area of New England. If you are in New England, then you are in Massachusetts. This is not necessarily true. So we're going to call that false, even though it could be. But you could also be in Maine. You could also be in Vermont. You don't necessarily have to be in Massachusetts. That's why this is a false statement, something that isn't always true. If you are in Hartford, then you are in Connecticut. Yes, Hartford is a city in Connecticut, so this would be true. If you're in Connecticut, you are in Hartford. This is not true. You could be in a completely different city. You might be in Hartford, but you might also be somewhere else. So that one is false. So a couple definitions for you. A conditional is an if-then statement. We often denote it by saying if P, then Q. So we'll put the letter and then we'll do that little line there with the arrow, and we read it as if P, then Q, or P implies Q. So we have a starting point, and that implies a second one. So here's also a diagram for it. If P, then Q. Notice P is the smaller one, Q is the bigger one, just like how we could say if you were in Massachusetts, you were in New England, right? The smaller inside the bigger. The hypothesis is the part P. Okay, so P is your hypothesis, and Q is called your conclusion. It follows the then. So here's a couple other examples. If a shape is a square, then it is a quadrilateral. So the shape being a square is the hypothesis. The conclusion is that it's a quadrilateral. This one would be true because a square is a type of quadrilateral. If an animal is a robin, then the animal is a bird. So we can use conditionals even outside of math, just like we saw in the previous one with the states and the cities. Here, if the animal's a robin is your hypothesis, the animal's a bird is your conclusion. And this one is also true because a robin is a type of bird. Write each statement as a conditional statement. Underline the hypothesis and circle the conclusion. Pause the video here and take a moment to do this. Dolphins are mammals. If we were to write this as a conditional, it should say something along the lines that if an animal is a dolphin, then it is a mammal. The animal being the dolphin is your conditional, is your hypothesis, and the conclusion is that it's a mammal. This would be true. A 130-degree angle is obtuse. If an angle is 300 or 130 degrees, then it is obtuse. This is also true because 130 degrees is larger than 90. The angle being 130 degrees is your hypothesis, and the fact that it is obtuse is the conclusion. All sharks have a boneless skeleton. If an animal is a shark, then it has a boneless skeleton, also a true statement. The animal being the shark is your hypothesis. The boneless skeleton is the conclusion. All numbers that are divisible by 9 are also divisible by 3. If a number is divisible by 9, then it is divisible by 3. The number being divisible by 9 would be the hypothesis. Also being divisible by 3 would be the conclusion. Every conditional statement is either true or false. So everything we saw on that previous page, those were all true conditional statements. In order to be true, every time the hypothesis is true, the conclusion must also be true. So everything needs to be true every single time. In order for it to be false, you have to find at least one counterexample where the hypothesis is true, but the conclusion is false. There might be instances where they're both true, but as long as you have that one counterexample, that one instance where it isn't true, then it is going to be a false conditional statement. So again, here's some practice. Pause the video for a second and try these on your own. If a woman is Hungarian, she is European. This would be a true statement. Hungary is a country in Europe, so all Hungarians are also Europeans. If a month has 28 days, then it is February. This is false. All months have 28 days. Most of them just have more. So that one is a false statement. Tricky one though. If a number is divisible by 3, then it is odd. False. The number 12 is divisible by 3, but it is also even. We could have had other examples. You could have had 6, you could have had 18, 24, numerous examples where we could have different ones that are even but divisible by 3. So related conditional statements. We can write our conditional statements in other ways and in other orders or negate them, which gives things different meanings. So the negation of a statement is the opposite of the statement. The symbol P with the little squiggle in front of it, okay, that's a tilde. So the symbol tilde P means not P. If P is the sky is blue, then not P would be the sky is not blue. So if we have a conditional statement, that's our given one. That's our basic one where you have the hypothesis, the conclusion, you have if P, then Q. Okay, so that's one we started with. The converse is where we switch the order. So now I have if Q, then P. The inverse is where I go back to my original conditional one, but now I'm going to negate both of them. So now I have not P implies not Q, or if not P, then not Q. Contrapositive is where we almost kind of combine our converse and inverse. So we're going to negate them both, but then we're also going to switch the order. So now I have not Q implies not P, or if not Q, then not P. I know those sound a little bit confusing, but let's take a look at an actual example, and I think you'll see how they work. So we have our basic conditional. If the measure of angle A is 15 degrees, then A is acute. This is true. 15 degrees is less than 90, so it's acute. The converse, again, is where we would flip them. So if you want to draw some arrows in, so converse means flip. Now I have if the angle A is acute, then measure of angle A is 15. Well, that's false, right? We could come up with other values. The measure of angle A could be 5. It's also acute, and it's not 15, so this would be false. The inverse, I'm just going to draw the little tilde there. Remember, that's our not. So I'm going to look at my original one and just say not. So if the measure of angle A is not 15, then angle A is not acute. Well, that's also false, right? I could use that same example of measure of angle A equaling 5. It's not 15, but it's still acute. So these two are both false. And you'll find that that happens in most cases. We call it the fallacy of the converse and the fallacy of the inverse. Contrapositive, remember, that's the one where we flip them, but we also negate them at the same time. So now I have, if angle A is not acute, then the measure of angle A is not 15. This would be true, right? If you're not an acute angle, you have to be an angle greater than 90 degrees, which means you definitely can't be 15 degrees. Most of the time, like I said, you're going to find converse and inverse are false, contrapositive will be true. So here we have the conditional statement, if it is snowing, then there are clouds in the sky. That's true, right? The snow has to come from somewhere. It comes from clouds. Our converse would be, if there are clouds in the sky, then it is snowing. Well, it could be true, but it also could be false. And remember, we just need one instance where it's false to make it false. Right? It might be rainy, or it might just be cloudy and nothing happening. Our inverse, if it is not snowing, then there are no clouds in the sky. And again, that's that same situation where there might be clouds in the sky and nothing might be happening, or there might be clouds in the sky and it might be raining. So this one is also false. Again, the fallacy of the converse and the fallacy of the inverse. If there are no clouds in the sky, then it is not snowing. This would be true. Again, snow has to come from somewhere. Has to come from clouds. So that one's also true. Now let's look at more of a math example. If a triangle is right, then a squared plus b squared equals c squared. Think back to your Pythagorean theorem from last year, right? We talked about this. We know this is true. Our converse would be, if a squared plus b squared equals c squared, then it is a right triangle. Well, this one's also true. So this is one where it works both ways. Remember last year, we talked about the converse of the Pythagorean theorem. Well, that's because we can actually use it. Remember, we can use a squared plus b squared equals c squared to show that a triangle is a right triangle. We can also show that a triangle is not a right triangle. So if a triangle is not right, then a squared plus b squared, it will not equal c squared. That's true, right? And again, we can prove a triangle is not right by using the Pythagorean theorem. If I try a squared plus b squared and it doesn't equal c squared, then I can conclude it's not a right triangle. So again, thinking back to algebra last year. As always, if you have questions from this lesson, please contact your teacher from your home school or check in with them the next time you are in class. Have a great day.